Assalamualaikum and hi everyone. Glad to see you again. Alright, today we are going to learn the last subtopic under thermochemistry, that is Born-Haber cycle. So these are the things that you are going to learn today. So define lattice energy and electron affinity, explain effects on the magnitude of lattice energy in terms of ionic charge and ionic radii. Explain the dissolution process of ionic solids. Construct Born-Haber cycle for simple ionic solid using energy cycle diagram and energy level diagram. And calculate enthalpy changes using Born-Haber cycle. So lattice energy can be symbolized as delta H lattice. Lattice energy formation is the energy released when 1 mole of solid ionic compound is formed from its gaseous ion. Based on this definition, so 1 mole of solid ionic compound is referring to the product side. So product side should remain 1 mole and the phase should be in solid. The ionic solid compound is formed from its gaseous ion. So if we want to balance the equation, then we have to balance at the right hand side. And the value of delta H formation should be negative value, which means heat is released. So usually for the formation of bond, so heat is released from the system to the surrounding. Okay, lattice energy dissociation is energy required to completely separate 1 mole of a solid ionic compound into its gaseous ions. So therefore, we want to separate 1 mole of solid ionic compound. We want to break the bond between an HCl solid. So 1 mole here should be at the right hand side. So if we want to balance the equation, you have to balance at the product side. And the product form should be in gaseous ion. And the value of delta H here is positive value. So because usually for the bond breaking, energy is absorbed from the surrounding to the system. So this is what we call lattice dissociation and this is lattice formation. The magnitude of lattice energy will increase as the ionic charges increases because ions attract each other more strongly. Okay, and it is also increased if the ionic radii decrease because they get closer together. For example, let's say for delta H for MgO is more negative than delta H for Na2O because Mg2 plus ion is smaller in size and has bigger charge than Na plus. So therefore, we can conclude that lattice energy for MgO is greater than the lattice energy for Na2O. Okay, electron affinity, we can symbolize it as Ea. So it is referring to the amount of energy changes to added 1 mole of electron into 1 mole of gaseous atom or ions in their ground state. So therefore, energy change here, it can be heat absorbed or heat release. So it can be positive and it can be negative. So for example, we have gaseous atom, okay, accept an electron. Okay, it will produce gaseous ion. And the value of electron affinity should be negative. So why it should be negative? Because this reaction usually exothermic, release energy. Okay, because when an electron is added to a neutral atom, so it will experience an attraction of nucleus and release an amount of energy. So the value of Ea are generally negative. The higher or more negative the Ea, the more easily it accepts an electron. However, affinity does not always release energy. In some cases, affinity requires energy, which means heat is absorbed. For example, like oxygen, so the first Ea, so would be negative value. However, once it becomes O minus gaseous ion, when it gains 1 electron and it will produce O2 minus ion. So therefore, Ea2 required energy where the value become positive. So Ea2 is positive because heat is absorbed. Why? In order to overcome the strong electron repulsion between the negative ions and the added electrons. Before we continue our explanation, right, so let us recap back what you have learned during previous semester 1, that is about first ionization energy. The symbol here is IE1. IE1 can be defined as the minimum energy required to remove an electron from a neutral gaseous atom in its ground state. So therefore, it should be in gaseous atom and 1 mole. Okay, remove 1 electron. So therefore, energy is required, which means energy is absorbed. So the delta H value or IE value should be positive value. Okay, second ionization energy, so IE2. So it can be defined as the energy required to remove an electron from unipositive gaseous ion in its ground state. Okay, unipositive gaseous ion here is referred that gaseous ion that have positive 1 charge. Okay, so for example, like X plus gas, remove an electron and it will become X2 plus gases. So energy is absorbed in order to remove 1 electron from X plus ion. Dissolution process of ionic solid. Okay, what is dissolution process? So it is a process by which a solid or liquid forms a solution in a solvent. So as we already know, water molecule are polar. So therefore, most of ionic solid crystal can dissolve in water. For example, like NaCl solid. So this is an example of ionic solid crystal. So it can dissociate in water, okay, and produce Na plus aqueous plus Cl minus aqueous. And the value of delta H solution is positive 4 kJ per mole, which means heat is absorbed in order to dissociate the solid ionic crystal into aqueous ion. Okay, ions in the solid crystal can be separated from each other and converted to gaseous ion. So this is referring to the lattice energy, which refer to the delta H dissociation. So the attraction forces between gaseous ion and the polar water molecule can cause the ion to be surrounded by water molecule. So this is referred to the enthalpy of hydration. So because it convert from the gaseous ion into aqueous ion. So we will get this relationship, that is delta H solution is equals to delta H lattice dissociation plus delta H hydration. Right, so this relationship we can illustrate by using this diagram. So let's say we want to calculate the delta H solution for NaCl solid that is convert into Na plus aqueous plus Cl minus aqueous. So we will get this cycle, energy cycle diagram. Okay, from NaCl solid, so it can convert it into Na plus gas plus Cl minus gas. So this is what we call lattice energy. From gaseous ion, so it can convert into aqueous ion. Okay, that is referred to the enthalpy of hydration. So therefore, if you want to calculate the delta H solution, it is equal to sum of delta H lattice dissociation plus delta H hydration.